Hey guys, we are here. We are going to be doing lesson 51. Lesson 51 is quite exciting. It involves imaginary numbers. Okay, so imaginary numbers. The first thing that I can tell you as we get started is this right here is a terrible name for these. It makes it sound way worse than it is. Okay, so don't let that totally freak you out because it's really not that bad. Once upon a time, negative numbers were something no one could imagine, and they figured them out, and we're fine with negative numbers. So we're going to be fine here as well. Okay, let's think here. If I have -3 and I multiply it by -3, I'm going to get 9. Right? If I take 3 times 3, I'm going to get 9. So when we square something, when we square a number, we always get a positive answer. Whether we're squaring a negative number or not, we're always going to get a positive. All right, so something squared is always going to be positive. Okay, and so because of that, we wind up saying that the square root of 9 equals positive or -3 because either one of those are going to work. Okay. And so when we look at the square root of 9 and we ask what is the positive root, 3 is the positive root. All right, if we want, so generally when we're looking at the square root of 9, 3 is generally what we want. If we want -3, we would normally look at this as the negative, and you think about negative sign meaning the opposite. So if I said I wanted the opposite of the square root of 9, the opposite of square root of 9 is going to be -3. All right, if I want the positive, I'm generally just going to write it this way. If I want the negative, we're going to put that negative sign out front. And if we want both, we want to have both roots, we're generally going to write that as positive and negative square root of 9, and that's going to give us positive and -3. Okay? All right. Let's look at some things here. So thinking about the square root of 9 equals 3. All right. We're going to think about the fact that the square root of 9 is equal to the square root of 3 times the square root of 3. And so that's going to equal 3 because it's 3 is that thing that's being multiplied by twice. All right. If I have the square root of 9 and I square it, the square root of 9 squared means the square root of 9 times the square root of 9, so that's going to equal 9, right? Just think about also the square root of 9 is 3, the square root of 9 is 3, 3 times 3 equals 9, or if I look at the square root of 9 times the square root of 9 is 9. Okay, over here that we had the square root of 9 is equivalent to the square root of 3 times the square root of 3, so that should equal 3. I don't know if I wrote 3 there a minute ago and accidentally erased it or what I did, but I just noticed there wasn't a 3 there. Okay, so thinking then the definition of a square root. If x is a positive real number, then the square root of x is the unique positive real number such that the square root of x squared is x. You can find that definition that I just read to you. It's there in lesson 51, so you might want to wind up taking a moment and looking at that. If x is a positive real number, then the square root of x is the unique positive real number such that the square root, looking at this right here for an example, the square root of x squared equals x, okay? The square root of x, if I take that and I square it, I'm going to get x, all right? Just some little foundational things there. So thinking along these lines, if I have -9, take the square root of that and I square it, that is equal to the square root of 9 times the square root of -9. So that's going to be equal to -9. All right. If I have a number line, all right, let's think about this for just a moment. And I have the square root of 81 is going to be equal to 9. And the opposite of the square root of 81 is going to be equal to the opposite of 9. All right, think about those things. So the square root of 80, the opposite of the square root of 81 equals negative 9. And down here on the number line, I can have a negative 9. Good. All right, and that negative 9 is equivalent to the opposite of the square root of 81. All right. I can have the opposite of the square root of 9 is equivalent to negative 3. All right. The square root of 9 is 3, and the square root of 81 is 9. All right, so on the number line, I can find the square root of 81, the square root of 9. I can find the opposite of the square root of 9 and the opposite of the square root of 81. All right, so I can plot all of those. What I cannot plot, though, is the square root of negative 9. All right, there is no number that I can square and get negative 9. There's no number that I can multiply by itself and get negative 9. All right, there's no such number. So what we're going to say is that the square root of a negative number is an imaginary number. Okay. All right. So let's think of that. The square root of negative numbers are imaginary numbers. They're numbers that we can't find on the number line. All right, we can do something with it, but we're not going to be able to find it on the number line. All right, so now I'm looking down. If you look further there in chapter 51, this is going to be 51b, the product of square roots theorem. All right, and what we've got going here, it says if m and n are real numbers and one is a positive number or both are positive numbers, then, excuse me. All right, the square root, so I've got that the square root of m times the square root of n equals the square root of mn. So that was saying if m and n are real and one is a positive number or both positive numbers, then this is going to equal mn. So the example that they give is the square root of 3 times the square root of 5 is going to equal the square root of 15. All right. The square root of negative 3 times the square root of 5 is going to equal the square root of negative 15. All right, we see that? All right, so let's look at this. What this is saying then, if m and n are both negative real numbers, all right, I'm going to have the square root of m, the square root of n equals the opposite of the square root of mn. Because think about it, if I had negative 3 times negative 5, I'm going to get positive 15. I've lost my negative sign. All right, so what we're going to do here is we're going to move that negative sign to the outside. So this right here was saying, the way the rule says, if m and n are both negative real numbers, so this right here, if this is a negative and if this is a negative, okay, then we're going to have this negative on the outside. We're going to put that opposite sign on the outside. All right, so the square root of negative 2 times the square root of negative 4 is going to equal the opposite of the square root of 8. All right, you see, so that we're preserving our number sign. The number is going to be on the outside. All right. Yeah, if we handled it like we would do a normal problem with the negatives, we would wind up getting a positive, and that would change our problem. Our problem would not be the same. Okay, over there on 51C, you see Euler's notation. Okay, so he's this Swiss mathematician. He introduces the letter I, and the I represents the square root of negative 1. All right, so we've said the square root of negative 1 is an imaginary number, and so what he said is when we have the square root of negative 1, we're going to represent that with the letter I. All right, think about the fact that negative 7 is equal to 7 times negative 1, right? All right, so then if I'm looking at the square root of negative 7, I can say that is equal to the square root of 7 times the square root of negative 1, right? So when then we've said that the square root of negative 1 is I. All right, so this square root of negative 7 is going to equal the square root of 7 times I. All right, so I'm just essentially taking this right here. I've got this square root of negative 7. I'm going to factor out the negative 1 and replace it with an I. All right, so here if I've got the square root of negative 6 is equal to the square root of 6 times the square root of negative 1, which is equal to the square root of 6 times I. Okay? Fairly painless. How about if I have the square root of negative 3, just the square root of 3 times the square root of negative 7, all right, that's going to be equal to the square root of 21I. All right. All right, we're going to move from there. Then they look from that to looking at complex number. Okay, complex number is really not, again, some of the names sound like more than they need to be. A complex number is just a number that has a real part and an imaginary part. So we're going to have a real and imaginary parts. Okay, so the example that they wind up giving you here is 4 plus 5i. All right, so this right here is a complex number. All right, so do know also this is going to be my standard form. So in my standard form, I would put my real number comes first, my imaginary number comes second. So if you wind up with 2i plus 3, you need to rewrite that as 3 plus 2i. The imaginary number should come second. Okay, so let's think for just a second about something else. Let's look at a couple of things. If I've got 2 plus 9i, and I'm going to add that to 4 plus 3i, all right, I can just go ahead and add my like terms. So this would be the same as 2 plus 9i, 4 plus 3i. It's going to give me 6 plus 12i. Okay. So we're just going to add like terms there. All right, easy enough. All right, let's think about this. We've got that I is going to equal the square root of negative 1. So then, if I have I squared, that's going to equal the square root of negative 1 times the square root of negative 1. All right, remember how the square root of 3 times the square root of 3 equals 3. All right, and remember where we said the square root of negative 3 times the square root of negative 3 also equals negative 3, and the square root of 9 times the square root of 9 equals 9. All right, well here the square root of negative 1 times the square root of negative 1 is going to equal negative 1. So I squared equals negative 1. I equals the square root of negative 1. I squared equals negative 1. Okay. All right, here's something just kind of interesting to think about for just a second. If we've got a number line and we have 0 here, and we have 2 here, and we have negative 2 here. All right. And I'm looking to go here from the 2 to the negative 2. So if I took 2 and I multiplied it by negative 1, I would get negative 2, right? Okay, so 2 times negative 1 equals negative 2. All right, well, negative 1 is I squared, so 2 times I squared equals negative 2. All right, the I, where the I comes in, the I doesn't move us along the number line straight from left to right. The I is a rotation into another dimension, so it's that third dimension. Okay, so with an I would come here with one I, and I would come here with another I. All right, so I squared is going to let me rotate from positive 2 to negative 2. All right, so the I rotates back 90 degrees. I rotates backwards 90 degrees. I squared rotates backwards 180 degrees. Okay, just something interesting there to look at. So then if I have 3I squared, that's going to be equal to negative 3. All right, 3I squared. I'm here on the number line with my 3. My I squared takes me 180 degrees backwards to the negative 3. All right, you'll get potentially further in that depending upon where you wind up going in your mathematics. You'll look at that. Okay, but for us for right now, we're just going to look at things like this. So I'm going to have not 3. I'm going to have 2. 2I minus 3I plus 2I minus 4 minus, or the square root of negative 4. So let's deal with that. Okay, so we know this I squared right here equals negative 1, right? So that's 2 times negative 1. All right, now I've got minus 3 times negative 1I plus 2I minus 4 minus the square root of 4I. All right, so see what I did there? So I just took each of my i's, and how can I translate that? How can I reduce my i's? All right, this 2 times the negative 1 makes that a negative 2. The negative 3 and the negative 1 makes that a positive 3, and I've got the I. I have the positive 2I, right? I've got the negative 4. Now then here I have the opposite of the square root of 4 is going to be 2, and then I have that I right there, right? Okay, so we can start combining things. These two right here, I've got the 3 and the 2 is going to give me 5I. And then I also have this negative 2I down here. So 3 and 2 is positive 5, and the negative 2 is going to leave me with a positive 3I. Okay, and I have a negative 2 and I have a negative 4, so I've got negative 6 plus 3I. There's the answer. All right. Let's look at another one here. If I have the opposite of the square root of negative 4 plus 2 plus 2I to the 5th. All right. That opposite of the 4, okay, so I'm keeping my opposite there, right? I'm going to make this negative sign be an I, and then the square root of 4 is 2. So this right here, the opposite of the square root of negative 4 is negative 2I. All right, and then I still have my plus 2. Okay, this right here, this I to the 5th equals I squared I to the 1st, right? So negative 1 times negative 1 times I, right? So that's just going to come out to be a positive I. Okay, so then I've got plus 2I. Okay, so now here I have a negative 2i, here I have a positive 2i, so this entire thing just comes out to be 2. All right, let's do one more of these real quick. All right, if I have 2i squared plus 5i plus 4 plus the square root of negative 9. All right, this I squared is going to be negative 1, so this becomes a negative 2, plus 5i plus 4 plus the square root of 9 is 3, and that negative sign is going to give us an I. All right, so I have a negative 2 and a positive 4 is going to give me positive 2. I have the 5i and the 3i is going to give me 8i. So there's the answer there. Okay, all right, and that is it for lesson 51. I will see you back for lesson 52.